In example 1.12, I will be classifying each of the mappings in examples 1.5 through 1.11 by looking at definition 1.8. Example 1.5 is on this slide, and I want to remind you of where we can find the mapping definition. I have it underlined. And from this mapping definition, we have the ability to represent it visually in one of two ways. We can use the Cartesian coordinate plane, shown here on the right, or we can create an arrow mapping, shown here on the left. At first, it'll be easier to use the arrow mapping to be able to identify and classify what type of mapping you're working with. I typically start with the first set, and I check to see how are all of the first set elements used. And I can see that I use all of them. I have to. That's part of the definition of a map. You must use all of the elements from the first set. And I notice that 1 maps to a single value, 2 maps to a single value, and 3 also maps to a single value. Now that doesn't immediately mean that I'm dealing with something that's 1-to-1, but as I look at the second set, I need to identify which elements are being used, and I don't have to use all of the elements from the second set, but of the ones that are being used, how often are they being used? I mean, how often are they being hit? So 2 maps to this 1, but that's the only arrow that ends up being pointing to it. 4 only has 1 arrow pointing to it, and 5 also only has 1 arrow pointing to it. So this does, in fact, represent something that is 1-to-1. So as I switch to example 1.6, we can see here that 1, 2, and 3 from that first set are used only once. But what I just outlined here was that 1 and 2 both map to the exact same element. So that's many that are mapping to just 1. So the 3 mapping to 1 represents a 1-to-1 type correspondence. However, if you have any of your mapping that has that many-to-1 aspect to it, that means that the overall field, the overall classification, is going to need to be many-to-1. In example 1.7, when I look at the first element from the first set, I notice that 1 maps to 1 and it also maps to 4, which would give me a 1-to-many classification. And the other elements, 2 maps to 2 and 3 maps to 5. So those are both a 1-to-1 type correspondence, but because I have that 1-to-many, that means that the overall classification is going to be 1-to-many. In example 1.8, we had the most number of ordered pair, the most number of correspondences, and it doesn't take a whole lot of analysis to start to figure out what's happening here. Take element 1 from the first set, it maps to 2, and it also maps to 5, which would be an indication of a 1-to-many type mapping. But if you were to look at 2 from the second set, you would be able to identify 3 different values. In fact, all 3 of the values from the first set are going to end up mapping over there. And that's an indication of many-to-1. So if you combine the 1-to-many and the many-to-1 ideas, you would end up with many-to-many. In example 1.9, we're going to find that all of the odd values, 1, 3, and 5, all mapped to 1. So that would be a representation of many mapping to 1. And I can also say the same thing for the evens. 2 and 4, they all mapped to 0, which should be another indication of many to 1. So since I have 2 of these many to 1 correspondences, I can say that the overall correspondence is going to be many to 1. In example 1.10, instead of looking at an arrow map, we're going to have to look at a T-chart. So from the T-chart, we can see that 1 maps to 3, 2 maps to 4, 3 maps to 5, 4 to 6, 5 to 7, but I'll put a little dot 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 here because that's not the end of the mapping. It continues on, but there's definitely a pattern here. So every element from the first set only shows up once, and any of the values that showed up in our second column, which are the ones that are coming from the second set, they also only end up showing up once. There's only one arrow pointing to them. So this also ends up being a one-to-one type mapping. The last map that we'll look at is example 1.11. And again, we have a table rather than an arrow map to help us in determining what type of mapping we're dealing with. But I'll notice the same trend that I did from example 1.10. 1 goes to 3, 2 to 4, 3 to 5. So it really doesn't matter what value I'm picking from the real numbers for that first column. Every time I map it to something, it only maps to one value. And none of the values in that second column are ever going to be repeated. So there's no way to create more than one arrow pointing to a single value. So this also tells me that I'm dealing with a one-to-one type mapping.